Hey y'all, it's me, Lowell again.
I just got done texting my girl Rosie in San Marcos.
We were
seeing how many different elements we could name. We got up to like 30.
Then
I could tell Rosie was totally cheating. She started busting out ones like germanium and bismuth and seaborgium. I totally called her on it.
Then she was
wondering, how do they organize all those elements?
I told
her there are more than the 30 we just named.
There's
almost 120.
So
I told her about the periodic table, how scientists arrange all the elements, and how they're classified by their properties.
Let's look at the
periodic table of elements.
Depending
on what book or website, the periodic table might look a little different.
But it will
always look more or less like this one.
Looks pretty
crazy, huh?
You can
see how many different elements there are.
The
periodic table is laid out in order of atomic number.
Let's write
that down.
Maybe you remember
that the atomic number determines the identity of the element, and it's the number of protons that determines the element's atomic number. So it's like the driver's license of carbon is 6, because only carbon has 6 protons.
This means
that carbon is the 6th element in the periodic table.
Chlorine is further down because its atomic number is 17. And copernicium is way at the bottom because it has 112 protons in its nucleus.
Alright, you get it.
And remember how we said protons and neutrons have mass, but electrons don't?
Well, the further down the periodic table you go, the more protons and neutrons are in the atom, so the heavier it gets.
So
hydrogen up there is the lightest because it only has 1 proton. Carbon has 6 protons and 6 neutrons.
This gives
it a mass of 12.
So it's further down the table. Gold
is down there because it's a pretty heavy element.
It has 79 protons
and a total atomic mass of 197. So it's even further down the line.
The
periodic table is kind of mapped in periods and groups.
The periods
are the rows and the groups are the columns.
Let's write
that down before you forget it.
So if you look at it,
the periodic table has 7 periods.
The two
rows at the bottom actually belong squished up with the rest of the table.
The reason
there are 7 periods has to do with where the electrons live in the atom.
Remember
how we said that the electrons buzz around the nucleus in a cloud? Well, we can also pretend they orbit the nucleus in a specific level of energy.
The number
of the period tells you the number of energy levels the atom has for those electrons to buzz around.
Check it out.
Hydrogen is on the first row, so it is in period 1.
If you look
at the atom, it only has one energy level for its electron to orbit around on. Carbon is in the second period,
so that
means it has 2 energy levels for its 6 electrons. And since gold is in period 6, it has 6 energy levels for all its electrons.
Now I want to talk about
groups.
Elements in the same group
have similar chemical properties.
That's
important enough to write down.
So
all the elements in group 3 act pretty much the same. Elements in group 17 have very similar properties.
And let's
see why.
Look
at carbon again.
See how
2 of its electrons fill up the first energy level, and there's 4 electrons out on the second level? Well, the electrons in the outer energy level are called valence electrons.
Let's look
at that definition.
You might
want to write that down.
The number
of valence electrons is real important. Elements in the same group have the same number of valence electrons.
For
example, let's look at 3 different elements.
Copper,
silver, and gold.
Since we
know a bunch about the periodic table, we can already tell a bunch about these guys. Copper's in period 4, so we know it has 4 energy levels for its electrons.
Count them up. Silver
is a row below, so it must have 5 energy levels.
We already know gold has
6 energy levels for all its electrons.
What else can
we tell?
Well,
since copper, silver, and gold are all in the same group, they must have the same number of valence electrons.
Yeah,
check it out.
They all have
1 electron all by itself in the outermost energy level.
Here's
why the number of valence electrons is so important.
The number of
valence electrons determines the properties of that element.
That's
real important to know. So since copper, silver, and gold all have the same number of valence electrons, they're put in the same group.
And
since they're in the same group, they must have the same chemical properties.
And that
makes sense.
What do we
know about copper, silver, and gold?
Here's
copper. heavy, shiny, bendable metal. Here's silver, another heavy, shiny, bendable metal. And gold, yep, heavy, shiny, and bendable. If you think about it, there's not a lot of differences between these elements. Unless you're in the Olympics, I guess.
And this happens all over the periodic table. Elements in the same group have the same reactivity because they have the same number of valence electrons. Elements in group 1 all react to water pretty violently. Elements in group 18 all gases that don't really react at all. And so on and so on. So I told Rosie that the periodic table isn't so crazy. Just remember that it's arranged in the periods by the number of the elements' energy levels. And also that the elements are put into groups by their number of valence electrons. And since the number of valence electrons determines the way an element reacts, all elements in the same group are going to have similar properties. Well, that's it for me. Until I see you next time, Slow the Same. There's always room for you in my periodic table. Bye, guys.